let's take a look at this example. Okay, so from where I supposed to start in this case? So I have given total current, and I know KCL. KCL says that I total is equal to the sum of the currents in this circle. So if I1 plus I2 plus I3 is equal I total. Okay, so simply I supposed to say that I1 plus I2, this is my I2, but my I2 is equal 2 times I1, that's why I'm going to write over here 2 times I1, plus I3, which is equal 3 times I2 is equal I total, which is equal 42 milliamps. Okay, let's take a look what we got over here. We have I1 plus 2 I1 is equal 3 I1 plus 3 I2 is equal 42 milliamps. Okay, so what I can do over here, actually I can factorize 3, and I'm going to have I1 plus I2 is equal 42 milliamps. I can eliminate this 3 by dividing both sides of my equation by 3. Okay, so I have I1 plus I2 is equal 42 milliamps divided by 3 is equal 14 milliamps. Okay, so the sum of two currents I1 plus I2 is equal 14 milliamps. Next, what I'm going to do, I'm going to write this formula one more time. So I have I1 plus I2 plus I3 is equal 42 milliamps. We found that I1 plus I2 is equal 14 milliamps. So these two currents together give me 14 milliamps. So that's why I'm going to write over here 14 milliamps plus I3 is equal 42 milliamps. Okay, so now I can find I3 by moving 14 milliamps to the right side of my equation. So I'm going to write this over here. So I3 is equal 42 milliamps minus 14 milliamps. 42 minus 14 is equal 28 milliamps. Okay, so this is my I3. Okay, so if I know I3, okay, let me write this down over here. I3 is equal 3 times I2. Okay, it's given over here. I3, the current which goes through resistor R3 is equal 3 times I2. So in order to find I2, I'm going to divide both sides equation by 3. So 3 and 3 will cancel out. And let's take a look what we're going to have. I2 is equal I3 divided by 3. So this is equal 28 milliamps. This is my I3 divided by 3. 28 exponent 3 negative divided by 3 is equal 9.33 milliamps. Okay, so this is my current I2. Current I2 is equal 2 times I1. Okay, so I2 is equal 2 times I1. Okay, I got this from the diagram. The current which goes through this resistor is called I2. I2 is equal 2 times I1. So in order to find I1, I'm supposed to divide both sides of my equation by 2. So 2 and 2 will cancel out, and I have I1 is equal I2 divided by 2. I2 is equal 9.33 milliamps. I have 9.33 milliamps divided by 2. This is equal 9.33 exponent 3 negative divided by 2 equals 4.66 milliamps. Okay, so this is my current I1. Okay, so next we're supposed to find the resistances. Okay, so we have R1 is equal VR1 over I1. Please keep in mind that we are talking about the parallel circuit. In the parallel circuit, the voltage across each resistor is equal to the voltage source. So VR1 is equal 12, VR2 is equal 12, VR3 is equal 12. That's why I'm going to use over here 12 volts. So I have 12 volts divided by I1. This is 4.66 milliamps. 4.66 milliamps. This is equal 12 divided by 4.66 exponent 3 negative. This is equal 2.57 kilo ohms. 2.57 kilo ohms. Okay, R2 is equal VR2 over I2. 12 volts divided by I2. I2 is equal 9.33 milliamps. So I have 9.33 milliamps. This is equal 12 divided by 9.33 exponent 3 negative equals 1.28 kilo ohms. 1.28 kilo ohms. 1.28 kilo ohms. Okay, and we're supposed to find R3. This is equal VR3 over I3. This is equal 12 volts divided by I3, and we found that I3 is equal 28 over here, 28 milliamps. So I'm going to write over here 28 milliamps. So I have 12 divided by 28 exponent 3 negative is equal 428.57 ohms. 428.57 ohms. Okay, so this is my R3. We found all voltages, we found all currents. Now we're supposed to find the powers. I'm going to write the powers over here. P total, okay, total power is equal I total times voltage source. I total is equal 42 milliamps times voltage source 12 volts, and this is equal 42 exponent 3 negative times 12 equals 5 or 4. 5 P total is equal 504 milliwatts. This is my total power. Next, I'm supposed to find the power at each resistor. So P1 is equal VR1 square over R1. So this is equal 12 volts over, of course, square over R1, and R1 is equal 2.57 K. This is equal 12 to the second power divided by 2.57 exponent 3. This is equal 56.03 milliwatts. Okay, now P2 is equal VR2 to the second power over R2, which is equal 12 volts to the second power over R2. R2 is equal 1.28 K. This is equal 12 to the second power divided by 1.28 exponent 3. This is equal 112.5 milliwatts. Okay, so next we're supposed to find P3. P3 is equal VR3 to the second power over R3, which is equal 12 volts to the second power over R3. R3 is equal 428.57 ohms. This is equal 12 to the second power divided by 428.57. This is equal 336 milliwatts. Okay, so now we're supposed to find the total power using these powers. So I have P total is equal P1 plus P2 plus P3. So this is equal, P1 is 56.03 milliwatts plus P2, which is 112.5 milliwatts plus 336 milliwatts. So I have P total equals 56.03 exponent 3 negative plus 112.5 exponent 3 negative plus 336 exponent 3 negative equals 5 or 4, 504.53 milliwatts. Now let's compare the results. Before I got 504 milliwatts, I got 504.53 milliwatts. As you can see, these results are very close to each other, so it means that all our answers are correct. And now we can say that the problem is solved.